We now look at the binomial series. Find the Maclaurin series for the function f of x equals the quantity 1 plus x raised to the k power, where k is a real number. As usual, we start taking the derivatives successively. The first derivative is k times 1 plus x to the k minus 1. The second derivative is k times k minus 1 times 1 plus x to the k minus 2. Using the power rule, the third derivative is k times k minus 1 times k minus 2 times 1 plus x to the k minus 3. We see that there is a pattern here. The nth derivative, we end up with the power k minus n. And so the n derivative is k times k minus 1 times k minus 2 all the way to k minus n plus 1 times 1 plus x to the k minus n. We then evaluate these derivatives at x equal to 0 because we're looking for a Maclaurin series. F of 0 is 1. F prime of 0 is k. F double prime of 0 is k times k minus 1. Because 1 plus 0 is 1. 1 raised to the k power is 1. The n derivative evaluated at 0 is k times k minus 1 times k minus 2 times ... all the way to k minus n plus 1. So the n derivative evaluated at 0 is the product from k to k minus n plus 1. Recall that the Taylor series is of the form c sub n x minus a to the n, where the coefficient c sub n is the nth derivative evaluated at a divided by n factorial, but in this case, a is 0. And so the function f of x equals 1 over x to the k is the sum, the n derivative evaluated at 0 over n factorial times x to the n. But the coefficients are k times k minus 1 times all the way to k minus n plus 1 over n factorial, and then x to the n. But this coefficient is K2s n, which is a binomial coefficient. That the function 1 plus x to the k is the sum of K2s n as the coefficient times x to the n. This is 1 plus kx plus k times k minus 1 over 2 factorial x squared plus ... The n term is K2s n x to the n plus ... This is known as the binomial series because it involves the binomial coefficients. Note that K20 is 1, K21 is k, K22 is k times k minus 1 over 2 factorial, and K2n is k times k minus 1 times all the way to k minus n plus 1 over n factorial. By the ratio test, if we look at the limit of the ratio of a sub n plus 1 over a sub n, note that the a sub n plus 1 is the a sub n term being replaced with n plus 1. So the binomial coefficient is the product from k all the way to k minus n divided by n plus 1 factorial. We can simplify the coefficient k minus 1 all the way to k minus n plus 1. We end up with k minus n times x over n plus 1. Because x to the n plus 1 is x to the n times x, cancelled out x to the n, and n plus 1 factorial is n plus 1 times n factorial. We factor the absolute value of x to the front of the limit. We end up with the limit of the absolute value of k minus n over n plus 1, which is 1. And so the limit is the absolute value of x, and by the ratio test, this series converges if the limit absolute value of x is less than 1 or negative 1 is less than x less than 1.